effect here. Same effect there. Everything works just as it does before. One thing I'll show you that's new is I've got a recipe called clean. This is standard practice, not required, but conventional, that one of your recipes says clean. And what it does, it doesn't depend on anything. But when you try to make clean, it removes any file that you could be building from other things that you can easily rebuild. So you don't want to remove main.c, but you do want to remove main.o, because you can always rebuild main.o. And so if I say make clean, it did a remove of everything.o and foo. And then typed in more than I wanted here. Okay. You can say, you can put multiple targets on the list. I want you first to do clean, and then I want you to do foo. To make sure I get a completely new copy of things. So here it is. It first did the clean recipe, then it did, since everything was gone, it had to rebuild everything. Right. Now let's look at it. It's got some new stuff. At the beginning, it's got macros. A macro is introduced by a name, and then an equal sign, and then content. There's a convention that your names shall be all caps. That's purely a convention, but you violate this convention at your own risk. It means that you cannot read your own files very well. Conventions are there to make things easier for you to read and for others to read. So I'm saying the compiler I want to use is the GCC compiler. Actually, it knows that by default, but if you want a different compiler, you can specify a different C compiler. These are the flags I'd like you to call the compiler with. -W all, turn on all warnings, and optimization level 3. The objects that I might want to build are main.o, input.o, and output.o. We'll see later, soon, how to actually refer back to these macros. The project I want is called foo. And the libraries I want, to get the libraries, I need this magic invocation. And I'm not going to define what that means. Dot suffixes is a pseudo target. It's a list of suffixes you can put on a file like .c and .o, so that if you've got a .c file and you want to make a .o file, it knows that the .c comes before the .o. That from a C you make an O. And in fact here, I give a recipe saying, it's very strange, this .c.o colon. It says, if you ever need a .o and you've got a .c, here's the recipe. Call your CC. Now, the way you invoke a macro is with a $ parenthesis. I didn't invent this. I would have invented something different, maybe. But that's the syntax. So this means use the macro for the C compiler, which I have up here. Put in all the C flags, which I've defined up here. Use the -C. And then this funny thing says the target. I'm sorry, the source, which is the .c. That's $- is what I'm coming from. It's the .c file. So this is a shorthand that for all of those lines before that said to compile this, use this recipe, to compile that, use this recipe. This says whenever you've got a .c file and you want to generate a .o file, use this recipe. So how do I get foo? Well, it depends on all the objects. What are the objects? I've told you here. How do you finally do the linking? You use GCC, you use the libs, which was this funny thing, of all the objects, now that they're up to date, and put the result in project. And project is foo. In fact, I should have called this project as well. I didn't. And then you echo project is ready. It still says foo is ready because that's my project. But then now you see, you can use much the same recipe file for other projects. If it's not foo, but something else, fine. You can put a different name in for the project. What does main depend on? Well, it depends on main.c and local.h. But it has no recipe. The recipe is here. So you're allowed to have a target and a list of dependencies and no recipe. You can have multiple ones of the same target and make a understands that all of these things on the right are prerequisites. So if you want to rebuild main.o, it depends upon these things. But here, the recipe isn't here. The recipe is this generic recipe for turning .c files into .o files. And here's my recipe for clean. It doesn't have any prerequisites at all. Instead, it just has, if you ever want to do a clean, do it this way. Remove all the .o's. I could have said objects here. And remove the project itself, the foo, because I can rebuild these. So you've got to be careful in your recipe for clean that it remove only the things you want. If you're not sure what it's going to do, you can always do a make minus f makefile 1, or 2 rather. You can always use a minus n. It says, don't do it, but tell me what you would do. So this says, this is what I would do. I'm not doing it because you asked me not to, but that's what I would do. You can look at that and see if that's really what you meant. I'm going to make it clean. And now I'll ask it again, what would you do? The answer is, that's what I would do because it doesn't depend on anything. What if I just said, make using makefile 2? What would you make at this point? This is what it would do. All of those things, because they're all necessary. If I take off the minus n, it now does it. If I now say again, what would you do? The answer is, nothing. It was up to date. So it'll tell you what it would do without actually doing it if you say minus n. And that's a pretty standard convention in Unix. There are a lot of programs which might do something, but if you say minus n, they just tell you what they would do. But don't count on it. Look at the manual page before you try that on anything. But that's often the case. Right? So I think I've shown you all of this particular one. Shorthands, makefile 3. All right. I've already shown you this one. The source file of a dependency is $-. The full name of the target is $ampersand. They made up a few of these pseudo variables. I've already mentioned that the default is the first target. And let me just go to Makefile 3 and let's look at it. It does the same thing as before. I do have a new thing for sources now, and I have a new thing for objects. This is kind of neat. It says, all the .c's are my sources. And so there's $wildcard. And what are the objects? It's all of the sources with a modification. Every .c becomes a .o. Occasionally I find myself using this, and I always have to look it up again, because I can never remember how to do that. These look the same as before. I've added now a new top thing called default. You can call it whatever you want, but that's the first rule. So if I don't specify what I want to build, it'll build the project now. And that means I can put the rest of the rules in any order I want. I can make it bottom up, top down, in any order, because my first rule now says what it is I'm really interested in doing, which is to build a project, which in this case is foo. I've added an ampersand here. Or is it an @ sign? An @ sign. Let's see if you can figure out what the difference is. Make minus f, makefile 3. Nothing to be done for default. Let's say make foo. Foo is up to date, just as good. Let's actually touch main.o and ask for the default to be built again. It had to relink because I said it had changed its date. And then it said foo was ready. There is a subtle difference. Do you see what it is? Yeah.
It didn't print the echo line.
Perfect. It did not print the echo line. Well, if I'm going to echo something, I don't need to see that it's going to do that. Generally speaking, make echoes, well, it prints what it's going to do at each step. And here it did. Print what it's doing. Well, I didn't want to see the call to echo. I wanted to see the response to echo. So putting an ampersand in front says, don't tell me you're going to do it, just do it. If you don't want to see any of the things, by the way, there's a way of telling make, be silent, it's -s. What else is new here? I've added a new rule called test. I often find myself doing this. If you want to test the whole project out, test depends upon the project. And once the project is ready, it runs it with input of my data and puts its output into my output. So let's, again, do that touch. And this time, do a make, saying make test. What should it do? It should first recompile, relink, because I changed an output file. And then it should run my recipe for test. And there it is. It first relinked, printed out that foo is ready, and then it ran it. Now what does it actually do? I don't care. It's a program I wrote years ago just to test things out. If we can look at my data and my output, it's not important for this purpose. So I have a recipe for doing tests. I have another run here, do error, just so you can see what happens when I try it. So I'm going to take off this minus. And I'm going to make do error and then run test. Now do error has only one command in it, which is false. Have you ever run the false program? False program immediately returns, but it returns an error. It doesn't return 0, it returns -1. It fails. Make looks at the return codes. And if any of these steps fails, it doesn't do the next step. So it says, it didn't even run test. It just ran the false and said, there's an error. I'm not going to continue. Another way of putting in an error, let me put the minus back in. When you have a minus, that means ignore it. Ignore the fact that it might have failed. So now if I do that again, it says, well, there was an error, but I ignored it, and I went ahead and did the next step. So this is very helpful if you've got a compile time error. So let's look at main.c, and let's put in an error. Like take out one of the parentheses. And now I'm going to, again, say make test. What should it do? Well, it should recompile main. But that should fail. I better give it the right Makefile. It's not done on this one, sorry. I'm doing it on this one. So, make test, using that Makefile. All right, it recompiled main. Warning, statement with no effect. Warning, okay, error. Make stopped at the error. It didn't continue. Now I can tell it to continue if I want, but typically when you're compiling stuff, you don't want make to keep going if there's an error at one step. And so usually that's exactly what you want. You can always use the minus if that's your intention. That's not what I wanted to do. I've got two windows here and I keep forgetting which is which. I'm going to put that back into its original state, write it out, go back to my talk, where I was, and now I'll run this again, and now it ran again. I recompiled it. This time it compiled fine. I had to relink it. It said that it's ready, and then it ran it. Right. So you've seen overriding, you've seen overriding a macro. This says, make using this Makefile, but change the macro C flags at the last minute. Ignore what's in the file. Put in a different one. So I only want 01 and I don't want any warnings. And then run clean and foo. So if I do this, it did the clean, which removed everything, then it had to recompile it, but it has a different flag now, because I told it. Override that. That's occasionally useful. You've already seen this. Okay, you've seen all of that. Using make for document preparation. It's not just for programs. It's for anything that you want to remember the recipe for. So, I have used nroff, or its descendants troff or gtroff for many years. In the last few years I've switched to tech. I've got recipe files for TROF and for tech. And so this particular handout happens to be old, and it happens to be done, as you can see, in TROF. Well, that's my Makefile. The Makefile looks like this. My goal is all. Here's where I want to publish it, and I just want to go to a different Makefile. So you can actually include a Makefile that we've built somewhere else. And so I've got this Makefile for NROF, and here it is. And I've been playing with it. It doesn't quite work at the moment, because it's been a long time since I've used it on this laptop. It still works on my regular machine. And so I've got, for example, a recipe for spell. And it says run iSpell from the goal, put the result into a file called spell, and then sort it and put it through less. And when you're finished, remove it. Well, let's do that. Make spell. Now, I didn't specify what Makefile to use, so it's using the one called Makefile. And it's spelling, it's checking the spelling on this document here. And here are the possible things. Now, every time a student submits a program in one of my courses, the very first thing I do is I check the spelling. I use a Makefile, of course. I use a Makefile for grading. I use a Makefile for everything. And so there are a few things that don't look like good English words. It turns out they're all fine. But they all appear somewhere or other in this document. So that's make spell. And there are other things I could make, but it's hard for me to show you that because it's not actually working. I think if I use tech instead, these actually do work. But, so I can change xfigs into PNGs. So if I build a picture with xfig and I need a PNG, this is how it's done. I can never remember that. There's the recipe. If I need to build a DVI file from a tech file, then I run it through LaTeX. And then, while the log says rerun to get references correct, I do it again. That's all in the recipe. I don't have to remember how to do that. I have PDF LaTeX, which I've got that commented out. Comments, by the way, start with a pound sign or a hash sign. Useful to know. I'm going to go back to the way it usually said, although it's not going to work very well when I try to actually make things with that. All right, I'm almost out of time. That's almost everything that you need or even don't need. There is, of course, a manual online. Just type into your favorite search engine, manual make, or GNU make, which is in fact the make that you get these days. And you'll find all sorts of other stuff you can do. But this is the parts of make that I do use. Questions? We have a little bit of time. Yeah?
What year was it?
In the early 70s. I'm not sure exactly what year. But Berkeley Standard Distribution came out with a make. And the GNU version was a non-copyrighted version of that.
Is it written in like C?
It's written in C. At least the original version was. I'm pretty sure the current version is written in C as well. Most systems programs are. Yeah?
I believe it was Makefile 2, but there was the dot suffixes.
Yeah.
What makes that's a different type of command than the rest of them?
Yeah, what that does is it says, it allows you to put in commands like .c, .o. You name what suffixes there are and in what order.
Is that like a thing hard-coded into the make program?
Well, the make program in its startup actually has a whole bunch of suffixes that it already knows about.
Okay.
So it already knew about .c and .o.
Okay.
In fact, it already knows about how to compile C programs. So I can play a funny game here. Let me just remove main.o. And I can say make main.o. Now it's using a Makefile that doesn't know how to do that. Because I didn't specify Makefile 1, 2, or 3. It's using my Makefile for programs, but I bet it will work anyway. Yep, it used CC because that's its idea. It didn't use any optimization because I didn't tell it to. But there are some built-in rules that it already knows about, including a bunch of suffixes. Yeah.
But is the dot suffixes in all caps, is that like a magic word?
It is.
Okay.
Dot suffixes, all caps, colon is a magic word. There are a few other magic words like that I didn't show you. Okay. All right. Out of time. Ask me more questions later. It's time to hear the success.